Okay, that's question number 4. Question number 4 reads, how much sodium hydroxide, NaOH, must be dissolved in 100 ml of water to prepare a 3.95 mole per liter? Okay, for such question, it is identified that it is taken from Unit 12.1, the first unit that is taught in grade 12 under stoichiometry. So when you look at it, they ask us to calculate the mass. That is actually the mass of sodium hydroxide that can dissolve in 100 milliliters of water to prepare a concentration of 3.95 moles per liter. Okay, 3.95 is actually the concentration of the sodium hydroxide. So first of all, this stoichiometry, we will have to use two formulas. The first one will be finding the mole, the number of moles of sodium hydroxide, and after that we will calculate the mass using another formula. Okay, I will go through the formulas. Okay, that's the first formula that we will be using. That's the first formula. Okay, that's the first formula. Its molarity, which is also known as the concentration, is equals to number of moles divided by the volume of solution in liters. Okay. So for this one, we do not know the moles, so we'll just put M, mole for moles. Okay. Divide by the volume of solution, it has to be in liters. So according to the data given, it is actually given in 100 milliliters. So here we will have to convert this 100 milliliters to liters. So here we just simply get this 100 milliliters. Okay, to convert it, is simply move 3 decimal places to the right. Okay, so it will be moles divide by 0.1 liters. Okay, for the concentration, it is given already here, above here, as 3.95 mole per liter. So here we will write 3.95 mole per liter. Okay, here also 3.95 mole per liter. Okay, when you look at it, two variables are given and you have to find the moles. So in order to find this one, we need to remove 0.1 liters. So we simply multiply by 0.1 liters. Whatever you do on one side, it's an algebraic equation, so you need to balance it, times 0.1 liters on the other side. So here, after you cancel this one off, you are left with the mole only. So here, just simply get your calculator, calculate 0.1 times 3.95, okay, 0.395. So you write 0.395. See, the liters have been cancelled off, then you are left with mole, which is the unit of the amount of mole. So 0.395 is actually the mole of sodium hydroxide. Okay, that's the first step. The second step, we have to find the mass. So I use another formula. So here, the mass is equals to the number of mole times the molar mass. Okay, for this one, you simply get the number of moles that you have already calculated at 0.395 mole, and then you substitute it in place of n. So it will be 0.395 mole, and then we multiply by the molar mass. That's the molar mass of sodium hydroxide. So the molar mass of sodium hydroxide, you have sodium as 23 grams per mole plus oxygen, which is 16, plus hydrogen, which is 1. Okay, so it will be 0.395 mole times 40 grams per mole. Okay, when you get your calculator, okay, 0.395, and then you multiply by the molar mass, which is 40, okay, equals, and that's your answer, 15.8. So the answer is 15.8 grams of sodium hydroxide. So when you come back here, okay, go back up here, you have 4 selective answers. Okay, the one that actually matches our answer is D, which is 15.8 grams. So again, that's our working out. First of all, you use the molarity is equals to moles over the volume, and after you have gotten the mole, you then use another formula, which is this one. Mass is equals to the number of moles times molar mass, and you should get the amount of sodium hydroxide that is needed to be dissolved in 100 milliliters of water to prepare a solution of, not a solution, but a concentration of 3.95 moles per liter. And thank you very much. Please click again if you forgot to subscribe. Please, if you see the subscribe button, I would like you to click on it. We have a lot of pages to cover for 2018, so subscribe, and also touch the notification bell, so if the next video that I will upload, you'll be the first one to be notified. Thank you very much, and I'll see you next time.